Hey there, year 11s. We are now going to apply exponential and logarithmic equations where we're trying to apply on our CAS and solve problems. So here, this is an example of what we call a cell growth example. So there are some terms that you need to get familiar with. In this case, it is what n naught, 2, and then this td. What does that mean? TD is called the generation time. And what that means is that it's how long does it take to reproduce itself again. So in this particular example, it's the growth of cells. So obviously a cell splits up after every, minutes. So TD minutes. And then after those minutes, these also split. So you can see that in this particular case, the cells divide into 2 new cells. So with cell growth specifically, we're going to talk about just splitting into 2, not 3 or 4. So this is why you can see that because you're doubling each time, this follows an exponential growth. That's what an exponential equation models. It models with a base 2 to the power of x that represents growing by doubling each time. Whereas if you had cell growth of 3, that implies that it triples every time, okay? So we know that's why it's a base 2. What else do we also know? Well, t is the time, and this says here that t is in t minutes and the number of cells, so n is the number of cells. So for the most known bacteria that can be cultured, generation times range from 15 minutes to 1 hour. In our case here, we're doing an example of what is the generation time. So they want you to find TD. This is what they want you to find, generation time, T of D, of a bacterial population that increases from 5,000. So you started off with 5,000 cells to 100,000 cells. So that's your final N in 4 hours. So they tell you that this is time, but remember, this is in hours when they already told you up here that T has to be in minutes. Okay, so I'm going to write here 4 hours, which is the same thing as 240 minutes. Okay, so they want you to find TD using the model that we understand for exponential equations. This is an exponential, it's cell growth. So we know that the model says it's N is equal to the number of bacteria is equal to what you start off with, multiplied to base 2, because it's splitting into 2s each time, so it's doubling, time divided by T of D, okay? So from here, you can probably start putting in the numbers and then see if you can solve the equation by hand, or you can do it on a CAS, but let's do both. I'm going to do here, we know that N, the final one, is meant to be 100,000, is equal to, you started off with 5,000, multiplied to 2 to the power of, remember, it's not 4 hours, it's 240 minutes over TD, which is generation time. So if I were to solve this, I would say get rid of the times 5,000, so divide 5,000 on both sides. 100,000 divided by 5,000 gives me 20 is equal to 2 to the power of 240 over TD. Here, what we would use inverse operation, so opposite of exponential base 2 is logarithmic base 2. So I'm now going to do logarithmic base 2 on the left, and also I'm just going to move this to a side so you can see. Oh, wow, what happened? Oh, there we go. We're going to do logarithmic base 2 on the right hand side as well. So this now gives me log base 2 of 20 is equal to, and remember these two cancel out, so you are now left with 240 over T of D, okay? And your goal is to find T of D, and here, depending on your algebra, how good it is, for me, I would simply times TD on both sides, so times T of D to both sides, because that's the inverse of divide by TD, and so these two will cancel out. I should do it in red. These two will cancel out, and I will now have TD multiplied to log base 2 of 20, whatever that is equal to 240. I'm going to give myself a bit more space. And from here, how do you get t of d? Well, I need to get rid of times log base 2 of 20. So I say, well, opposite of times is divide, so divide by log base 2 of 20. See what I'm doing? All I'm doing is just inverse operations the whole way. And these two cancel out to be 1, and that's why we know it's TD is equal to 240 over the log base 2 of 20. And that's where you then use your calculator to calculate what this equals to approximately. So I'm going to go to my CAS and let's work this one out. Clear history. We've got 240 divided by log control 10 base 2 of 20, control enter, and that gives me, over here I'm just going to print screen to bring it over. Here we go, let's zoom out a bit. And that gives me, on the side here, that tells me that it is 55.53, correct to do decimal places, so 55.53 correct to 2 decimal places. And if they're asking for the generation time, so generation time is then approximately 55.53 minutes. Okay, that's how long it takes. So make sure to put your units in. But that's how you would do that by hand. If you would do it by a CAS, you could have just done menu 3, so algebra, and then 1. So menu 3, 1. And you can type in the equation. So it was 100,000 is equal to 5,000 times 2 to the power of, and we had x, you can call it t if you want. Actually, it was 240 over x, and that's what we wanted to calculate. So comma x, solve for x, and there you go. That would also have given you the answer if you had just gone straight to your CAS. So it's just a bit of CAS or a bit of algebraic work there, but either way,